Let's start with a big picture. Large portion of our drinking water comes from the ground, and we can all understand that it is important to protect the quality of this resource. Arsenic is a naturally found metal and is highly toxic. It is also the biggest culprit for the contamination of groundwater worldwide. Currently, millions of people in the Southeast Asian countries are affected by it. I've witnessed the issue of arsenic contamination firsthand. While living in the Indian state of West Bengal, I saw a hand pump in a house with a label marked with this red plate, warning for serious levels of arsenic, while just next door, a hand pump was pulling out low arsenic groundwater. So why is arsenic present in water, and where is it coming from? We've known for some time that arsenic enters into groundwater from sediments around it. Well, that's your question answered, right? Well, just wait for a sec. Zoom in and look at the smaller picture. The sediments can be classified into two types. One that release arsenic, while the other that can remove arsenic from the water. Furthermore, arsenic can move with groundwater from one point to another. But the actual processes that can remove arsenic from water and can make groundwater safe was still not identified. And for people living in the arsenic contaminated areas, all they wanted to know is, will arsenic come out of their hand pumps tomorrow? In my research, I've conducted numerous laboratory experiments with the sediment samples collected from a field site in Vietnam. These experiments mimic the chemical conditions found in the nature. I then developed models that use the power of supercomputers and analyze the data. I have identified 5 different processes that can remove arsenic from the water. The groundwater flow at the Vietnam site is well understood. And when I applied my arsenic model to the site, I found that arsenic was spreading at a low rate. But things could get worse with an increasing demand for groundwater. Well, my work is not just limited to the developing nations of Southeast Asia. Australia and rest of the world will find my work useful for their own arsenic problem. Every year, more and more data is being collected on arsenic, and my work could help improve the understanding of that data and make better predictions of the arsenic movement in future. I hope I've answered a lot of whys in this talk, but I do hope there will be more questions to ask, because I do love to ask the question, why? Thank you.